Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
Today, in our 325th episode, we have a bunch of news, including a new sauropod, and it's the very last of the dinosaurs that were named in 2020 that I plan on covering.
Way to end on a high note.
I suppose. And even though I say it's a new sauropod, it's a new sauropod name, but it was actually found way back in the 1800s. So it's one of those dinosaurs, like the Madagascar one we were talking about. And we have Dinosaur of the Day, Brontomirus.
And a fun fact.
Yeah, Sabrina's doing the fun fact.
Garrett's all thrown off. It's great.
As always. I snuck fun facts into my news item so that I didn't have to miss out completely on the joy that is delivering a fun fact. But before we get into that, real quick, we want to thank our patrons. We want to thank all of our patrons, but specifically, we have a new patron, Arlosaurus, who joined very recently. And rounding out our shoutouts are Kessler, Scotty, Lorosaurus, Brad Shelby, Jared Copeland, Gabe, TRX Dinosaurs, Stego Sophie, and Greg.
Yeah, thank you so much. Thanks so much for being part of our dinosaur enthusiast community.
Sharing the dinosaur enthusiasm with us.
Yes. The dino love. And if you want to join our growing community, then check out our page at patreon.com/iknowdino. We've got a Discord where you can chat to your heart's content about dinosaur news and other things. And we have all kinds of other rewards too.
Yep. So jumping into the news.
Sauropod.
Yep, exactly. So this new sauropod was described by John Whitlock and Jeffrey Mantia and published in JVP, or the Journal of Vertebrate Paleontology. And the sauropod is from Cañon City, Colorado. I think some people pronounce it Canyon City.
I've heard that.
But it's got an Enye, so it really seems like it should be Cañon. Anyway, it's in the Morassaurus Formation, which means it's in the late Jurassic with all of the North American sauropod greats like Diplodocus or Diplodocus, Apatosaurus, Brachiosaurus, Camarasaurus, and more recently Brontosaurus when it got
the greatest
revived.
Of the greats?
Yes, I think so. Except for, I should point out, if there's any Alamosaurus fans listening, that one is also great. The only known titanosaur from North America in the Cretaceous. But other than that, pretty much all the well-known sauropods are from the Morrison Formation. It's really the formation for you if you're a North American sauropod fan. But have you ever heard of Morosaurus?
That sounds vaguely familiar.
It was a little familiar to me too, but I think I was just mixing it up with Moros, which was a tyrannosaurid that was named in 2019.
Okay, that could be it.
But you might be familiar with Morosaurus because it was named by Marsh in 1878, and then in 1919, Morosaurus was mostly synonymized with Camarasaurus.
So it's a Bone Wars dinosaur.
It is, very much so. Camarasaurus was named 1 year earlier by Cope, and then Morosaurus, a year later, was named by Marsh, and it was basically the same as Camarasaurus.
Cope won that one.
Yes, he did. But I said that Morosaurus was mostly synonymized with Camarasaurus because, like all of these Bone Wars dinosaurs, they had a whole bunch of species, and the taxonomy is really complicated. They actually have a table in the paper where it has all the different species of Camarasaurus and Morosaurus and when they got reclassified and if they got reclassified over decades and over a century, actually, of different papers and analyses. It was very messy. In the end, Morosaurus was basically stripped of its type species, so anything that was left, which mostly includes this one called Morosaurus agilis, was just sort of left in this weird taxonomic limbo because Morosaurus was basically thought of as a synonym of Camarasaurus, and then there was this dinosaur called Morosaurus agilis, which was still known. People know about it, and it's a pretty important find, but the name Morosaurus was very confusing since it's synonymized. Those Morosaurus agilis bones were found in 1883, which is why they were still Morosaurus and not named Camarasaurus, because Morosaurus didn't get synonymized into Camarasaurus until, I think, 1919 about is when it started to shift by Gilmore. That actually happened with a lot of these Bone Wars dinosaurs. Both Cope and Marsh died thinking they had named all of these valid dinosaurs and that they had won these various battles. And then people later went back and axed tons and tons of these goofy names they came up with.
Yep. It was hard to find a list, but the list is very small compared to the number they named. Names that are still valid today.
Yeah, we had a fun fact a little while back, and we said that Marsh named 80 species, 23 are still valid, whereas Cope named 64, but 9 are still valid. So between them, they named almost 150, and a little bit less than 30 are still valid.
That's a big difference.
Yes, for sure. But I think most of them were still valid when they both died in around 1900. So Morosaurus or Morosaurus, I'm not sure which, agilis, was found in 1883, and they got categorized as USNM 5384, which means they're at the Smithsonian. USNM is like the United States National Museum abbreviation. And then they got assigned to the new species in 1889. But even though they're in this weird taxonomic no man's land, the find is really significant. So it's a partial skull, including a brain case, skull roof, and a third of the sclerotic ring. Those really cool eye bones that are fascinating that animals even have bones in their eyes sometimes. It's so weird. But birds still have them. I think all birds have them. I tried looking that up for a comparison, but I couldn't verify that every bird has it, and I'm a little bit reluctant to say that because almost every time that I speculatively say that everything is a certain way in biology, it turns out not to be the case.
Especially when there's such variation in birds.
Yes. But I think, as far as I know, I haven't found a bird that doesn't have a sclerotic ring. And we think most dinosaurs did too. In addition to that partial skull, it's also got an articulated set of 3 neck vertebrae attached to the skull, basically. And there are also some loose fragments, including part of the orbit, still in the collection. Although originally there was a little bit more. There was more of the frontal, sort of around the orbit, going, I guess, the top back of the head forward above the eye a little bit. We had a little bit of that piece. And we know that because there's the original 1883 field sketch still preserved, which is a really good drawing. These people were amazing. I guess without photography easily available, they got really good at drawing. So you can see all these details of the skull, and a big piece of it is not
It's nice
there
it's
anymore.
still preserved, too.
Yeah, at least most of it is. And at the time, it was one of the most complete sauropod skulls known anywhere. Basically, Diplodocus was known from a complete skull, and I think this might be the second most complete one in 1883 or maybe even 1889. So
pretty important find.
Yeah, people were really excited about it. It definitely warranted its own species name because you could see all these details that we didn't have in other dinosaurs. Unfortunately, though, since the type species of Morosaurus, I think it was Morosaurus grandis, got synonymized into Camarasaurus, and then all these other Morosaurus species got pulled over into Camarasaurus over the years, it's basically just Morosaurus agilis that was sort of floating in this weird half existence of not really synonymized. So these authors wanted to give a new name to the genus so that we knew how to talk about it. And what they came up with was Smitanosaurus. It also looks like Smitanosaurus. It's spelled Smitanosaurus.
Okay. But it's meant to be like about smiting?
Yeah, that was my first guess. They say it's from the Old Saxon smiten, which means smith.
Oh, okay. That's why it looks like Smith.
Yes. It also references 2 smiths. There's J. August Smith, who excavated and sketched the holotype. And then there's also the Smithsonian Institute where it's housed. That's where they say they got the naming from. But since they specified it comes from the Old Saxon smitan or smiten first, and they did a little line over the eye to indicate that it's a long eye. I think that they want it to be pronounced Smitanosaurus, but I don't think they would be too upset, at least I would guess they wouldn't be, if you pronounced it Smitanosaurus, since smiten got anglicized into Smith with the shorter I.
Right.
I think smitten sounds more like Smith, which is what it's named after.
Although I wouldn't think of Smith necessarily when I first heard Smitanosaurus. I think smiting, and even Smitanosaurus, I think, oh, smitten, like smitten with this dinosaur or something.
Yeah, I kind of like Smitanosaurus because it sounds like a cuddly dinosaur or something. But my best guess is Smitanosaurus, but I could be wrong. Fortunately for the area Smitanosaurus is from, we have some radiometric dating, so we know it's about 152 million years old, right there in the normal age of a Morrison Formation find. And it probably wasn't fully grown. We know that because the skull wasn't fused, like the sort of like a baby with a soft spot. The different parts of the bones in the skull aren't fused together. And the vertebrae also weren't fused. In fact, cervical ribs are usually fused to the neck vertebrae. They sort of go parallel to the length of the neck, and they weren't there at all. So the assumption is they weren't fused, and then they basically got washed away or scattered or whatever during the taphonomy and the fossilization process, and that's why they weren't preserved. Sort of the opposite we were talking about with that Tyrannosaur from China, and how we could see broken pieces, and therefore we figured something must have been fused, and so it was probably an adult. This is like the opposite of that, where something's missing, and where it should be fused, it doesn't look like anything was broken off. So another piece of evidence that it was probably not fully grown and skeletally mature. But even with that, the authors say it was pretty big for its relative immaturity level. So Smitanosaurus might have been a large sauropod when it was fully grown. But it could also be that the bones just fuse later in Smitanosaurus than in its relatives, so it just looks younger than it is. There's a lot of variability in dinosaurs too. It could also just be individual variation, that this one was a late bloomer in terms of skeletal fusing. And there isn't too much information on the size of the animal, since we just have part of a head and a few vertebrae. But just for your reference, the largest vertebrae is 10.2 centimeters long and 10.3 centimeters high, or about 4 by 4 inches. So it's still pretty big. I mean,
yeah, that's a good size.
It's way bigger than any of our vertebrae. I tried to look up how that compared to an elephant vertebra, but I couldn't easily find it. I think it's sort of in the same ballpark. But again, these are the vertebrae closest to the head, so they are expected to be pretty small relative to a mid-neck vertebra. I thought it was really cool that they found the sclerotic ring, but unfortunately they only found about a third of the ring. It was still enough to estimate that the full sclerotic ring would have been roughly 3 centimeters in diameter, or just about an inch. And that means the eye would have been just a little bit bigger, because sclerotic rings are sort of near the diameter of the eye. I think, as far as I can tell, they sort of go around the iris, more or less. At least that's where it would be on our eye. I'm not sure how big dinosaur irises were, but yeah, they sort of support the edge of the eye. It's not like a little tiny ring around the pupil or something. It's a lot closer to the edge of the eye. So it would have been bigger than a human eye, which is about 2.4 centimeters in diameter, since it was around 3 centimeters in diameter of sclerotic ring. So the eye should have been a little bit bigger.
Although that's interesting to think about. I always think, since dinosaurs, especially with sauropods, because not all dinosaurs are so much bigger, but with these larger dinosaurs, that their eyes would also be bigger.
Yeah. If you did because they sometimes come up with weird relationships. We talk about like the upper leg to lower leg ratio and stuff like that. In the vertebrae to eye ratio, like compared to us, our eye isn't that much smaller or bigger. It's in the same ballpark of size as our vertebrae. Whereas on this thing, it's got this huge, softball-sized vertebrae and a much smaller eye, relatively speaking. But then again, sauropods had kind of small heads. And if it was a daytime animal, then, because I think humans and mammals in general have big eyes because we're descended from nocturnal animals. So maybe that's why we have bigger eyes.
Because that's how we survived the dinosaurs.
Exactly, yeah. They were dominating all day. We had to sneak out at night when they weren't looking. Couldn't see us with their little eyes.
Yeah.
And as a fun fact, an ostrich eye is apparently the biggest eye of any living land animal.
Of course it is. Does that mean whales have bigger eyes?
Well, I know that some of the cephalopods, doesn't a giant squid have a crazy huge eye?
Oh, probably.
But then again, they're a totally different branch of animals.
Yeah.
Yeah, they're way distant cousins.
Right.
And I think their eyes evolved separately, because the way eyes function in humans and other vertebrates is the eye is like an extension of the brain. The retina is it's literally part of the brain. Whereas in cephalopods, it's a separate structure. So maybe that's why they could grow bigger or something. I don't know. But ostrich eyes are about 5 centimeters in diameter.
That's very large.
Yes. And according to the British Natural History Museum, that's bigger than its brain.
Wow.
So I guess if you say it's part of the brain, then it's like most of its brain is the eye.
Mm-hmm.
Maybe, I don't know if the whole eye counts as brain. It might just be like the optic nerve and the retina or something, but still massive. And when you look at the skull of an ostrich, and most birds for that matter, you can tell that their eyes are a huge portion of their skull.
Mm-hmm.
Whereas with sauropod skulls, that's not what it looks like.
So the ostrich eye was bigger than Smitanosaurus eye.
Yep. Probably bigger than most non-avian dinosaur eyes would be my guess. Whereas this sauropod's eyes, Smitanosaurus eyes, were just a little bit bigger than ours, even though their body was so much bigger.
It's weird to think about.
Yeah. And then in terms of what Smitanosaurus is related to, fortunately, the skull and vertebrae are pretty useful for phylogeny when it comes to sauropods especially. And in the sauropod family tree, Smitanosaurus came out as a diplodocoid, which is the other major group opposed to Macronaria. Macronaria is where Camarasaurus is, where the other Morosaurus were lumped into. So it's a good thing this one didn't get included with those, because it's clearly not a Camarasaurus. And it's not even in the same group as Camarasaurus. It's over on the other side of the sauropod family tree. And if you want to be a little bit more specific, you could say it's a basal dicraeosaurid, which is, again, like a lot of these family names, the dicraeosaurids are named after Dicraeosaurus, which is a Cretaceous one. It's pretty derived. And it's also close to a Margosaurus, the one with the cool neck spines.
Mm-hmm.
Whenever I hear dicraeosaurid, I imagine all the cool paired neck spines on a sauropod. But I don't think they all had that. There's no indication that Smitanosaurus had those cool paired neck spines.
Right. And if it's a basal one, then it's less likely to have all the unique features.
Yep.
Yeah.
Yeah, so it's more of like a typical sauropod, you would say, for anything basal.
But again, they've only found the skull, really, so...
But they have the neck vertebrae, so you might
true.
be able to see the spines if they were there. It's also pretty close in relation to Chaotodocus, which also showed up as an early dicraeosaurid in their analysis, which was a little bit of a revision on where it used to be. But there is a little bit of an asterisk when it comes to Smitanosaurus, because the authors point out that juveniles sometimes appear as basal members of a group.
That's a good point, because they're not fully developed.
Yeah, and we know that sometimes derived dinosaurs and other animals will sort of re-inherit juvenile characteristics as an adult characteristic.
Mm-hmm.
It's this weird thing that happens. It's called either paedomorphism or apparently juvenilization. It's a little more obvious of what it means. So that could mean that Smitanosaurus is really just a juvenile version of an existing sauropod that we've already named and we already know more about, but we just don't have a juvenile, so we don't know that that's what it looks like as a young individual. And it could also be an existing sauropod that we don't have the head and the tip of the neck of, because since that's all we have of this dinosaur, if there's no overlap with another dinosaur that already has a name, it could get synonymized later, which is kind of weird because this was one of the earlier finds, but it could get synonymized with something that was found later because it didn't get named and then renamed until later. It's so messy.
Yep, that's what happens with bone war dinosaurs.
It is, yeah. But that's our last dinosaur from 2020, a Smitanosaurus.
All right, now onto the sauropods of 2021.
There are already a couple. I think I covered one that was technically published in 2021, but sort of like pre-published or published online in 2020 at this point. But this one was firmly in 2020. Pretty interesting history, though. I like hearing about the changes over time and these sort of dinosaurs that stick around for 100 years in like a weird limbo and then finally get their day in the sun.
Took longer than 100 years.
It did, yeah.
Well, many millions of years.
Oh, that way.
And in other news, I've got some quick museum news items. So the first one is that the Denver Museum of Nature and Science has a new exhibit, Sue the T-Rex Experience.
Interesting.
Yeah. So they've got full-scale casts of Sioux and a Triceratops, and you learn how Sioux was found. You can feel dinosaur skin.
Oh, really?
Yeah, you can hear T-Rex rumble sounds.
I wonder if it's real dinosaur skin. I suspect it's probably like a cast replica or something.
I think so, yeah. But the whole idea is to learn about Sioux, and then you see other fossils of fauna that lived alongside Sioux, and then there's a replica of a T-Rex fighting an Edmontosaurus.
Fighting, huh? It seems like a pretty one-sided fight between an Edmontosaurus. It seems like Edmontosaurus, if it's winning, it's fleeing and successfully escaping, sort of like a cheetah fighting a bunny.
Maybe. Don't know what kind of tricks those Edmontosaurus had up their sleeves.
I suppose, yeah. Maybe they had some good claws or something. Do a tail whack of some sort.
Yeah. So the exhibit's open from now until April 25th, and you buy tickets in advance for specific times to go in.
When you said Sioux the T-Rex experience, I was imagining there was some way to experience what it's like to be Sioux. But it doesn't sound like that's included.
Not that I've read, but I only read a brief description. I'm sure it didn't cover everything that's in there.
I think it's because there's a lot of VR things that end in like experience. It's like you could experience what it's like to be on the moon or on Mars or whatever. I want to experience what it's like to be Sioux.
Then you got to play one of those games where you can play as a dinosaur.
Yes.
And last, in Santa Barbara, California, the Santa Barbara Museum of Natural History is reopening their Prehistoric Forest exhibit, which I think we talked about it because it was a temporary exhibit in 2019, and now it's a permanent thing there.
Cool.
Yeah, so you can see animatronic T-Rex, Stegosaurus, Triceratops, Parasaurolophus, Euoplocephalus while walking around in this kind of foresty area.
Pretty typical sort of outdoor animatronic dinosaur situation.
Yeah, it looks like a nice place to walk.
I think that's the first natural history museum we went to together.
Probably.
Since we met in Santa Barbara.
Yeah.
I don't think they had any dinosaurs there at the time, though.
No, they had the whale skeleton.
Yeah.
They still do, I should say.
Yeah, that was probably the closest thing they had to a dinosaur was a whale skeleton.
Yeah, that's not very close.
No. Well, I guess actually there's probably some birds in there that are technically dinosaurs.
True. They also have a very cool butterfly exhibit.
And a planetarium. It's a good spot.
It is. So if you want to see the dinosaurs now, you can buy tickets online. And now onto our dinosaur of the day, Brontomirus, which was a request from Thieving Raptor Lorenzo via our Patreon and Discord. So thanks. Also thanks to the authors for putting that pronunciation in the paper.
Yeah, that's a huge help.
So Brontomirus was a Camarasauromorph sauropod, possibly dubious, that lived in the early Cretaceous in what is now Utah in the U.S., in the Cedar Mountain Formation. And it looked a lot like other sauropods. You know, it's got the long neck and tail, but it also had really powerful thighs.
Interesting.
So maybe it was a strong kicker or a good hiker, like climbing up hills kind of thing. So Brontomirus had unusual hip bones that would have allowed these large leg muscle attachments. Actually, these would have been the largest leg muscles of any sauropod. And the hip bone projects way forward from the socket. The ilium has attachments for abductor muscles, and that would have allowed Brontomirus to move its leg away from its body.
That's really interesting. I wonder how or if it might have been changed by the recent SVP presentation we saw on the really long cartilage attachment to the hips that they think was probably on there and allowed for like really long muscle attachments as well. Because maybe even though the bone wasn't really big with muscle attachment points, there could be other muscle attachment points that were soft tissue that didn't preserve.
Oh, maybe.
But I guess this is better evidence than we have for the other dinosaurs.
So Matthew Wadle, who's the co-author of the paper that named Brontomirus, has described Brontomirus as, quote, more athletic than most other sauropods. They didn't see strong muscles on the back of the leg, so it may not have had these strong thigh muscles for speed, but it could have instead allowed it to be a strong kicker, and it could have kicked in defense against predators like Utahraptor or Deinonychus, or maybe it would kick to fight over mates. It's also possible it had these thunder thighs, and I say thunder thighs because that's what the genus name means.
Oh, really?
Yeah, to help it walk through this rough, hilly terrain. So Waddell has described it as a, quote, sort of dinosaur four-wheel drive. It's also possible that it could have occasionally stood on two legs or even sometimes walked on two legs, or that it had really long legs and then needed the muscles to control them, but it's unclear since no leg fossils were found. If it did have really long legs, then it probably would have looked pretty giraffe-like. The shoulder blade of Brontomirus had unusual bumps, which probably show the boundaries of muscle attachments, and that means it may have had powerful forelimb muscles to go with its powerful thighs. 2 fragmentary specimens were found, probably of an adult and a juvenile. And maybe the adult was a parent to the juvenile, but there's no way of knowing for sure. That was something that just got kicked about.
Can't do DNA tests on dinosaurs, unfortunately.
Yeah.
No paternity or maternity tests.
Also, there's paleoart that shows a mother Brontomirus protecting a juvenile by kicking a feathery raptor.
So they're leaning into the parent idea.
Not everyone is. Actually, Michael Taylor, who is the main author of the paper, had this really great series of resources talking about the find, and one of the things is this FAQ specifically saying, no, we don't claim it to be a mother and child.
Gotcha.
So Brontomirus was estimated to be 46 feet or 14 meters long and weigh 6 tons as an adult. And the juvenile smaller specimen was about 15 feet, 4.5 meters long, and weighed about 440 pounds or 200 kilograms. That's
a lot smaller.
Yeah. So being a sauropod, you might guess, yes, it's herbivorous. The type species is Brontomirus macintoshi, and again, the genus name means thunder thigh.
That's so funny.
Yeah. And the species name is in honor of John McIntosh, who's a retired physics professor at Wesleyan University in Connecticut, who spent his free time studying fossils in museums around the world, and when he retired, he studied sauropods. So the paper described him as a, quote, veteran sauropod worker whose, quote, seminal paleontological work, done mostly unfunded and on his own time, has been an inspiration to all of us who follow, end quote.
So John McIntosh is not known for having thunder thighs. That's not why they associated.
No, it's more that he is an inspiration. And I think it's because Mike Taylor, the main author, did something similar where he got into paleontology outside of his day job and then ended up publishing a bunch of papers.
Nice.
So Brontomirus was found at the Hotel Mesa Quarry, which is a site where private collectors had already excavated a number of fossils. It's unclear what else has already been found there because of that, and the team that found Brontomirus found a lot of broken fossils.
So maybe it could have been more complete if they got there earlier.
Yeah, maybe there were leg fossils to be found. So Brontomirus is a pretty basal Camarasauromorph, but it's hard to tell because you just need more fossils to know more. And again, it's possible that there are more Brontomirus fossils in private collections. So in the paper that named Brontomirus, they said, quote, given the density of bones still present and exposed, and the fact that the existing quarry was already some 5 to 6 meters long and 3 meters deep, it appears that a considerable number of elements were removed from the quarry and that the loss of valuable scientific information has unfortunately been considerable. Bones left exposed by these previous collectors were in various states of disrepair, end quote.
Oh, so it's not even like they're in somebody's collection and then maybe later on we can find them and associate them with this. It seems like they might have just been disregarded and left out in the open in the harsh winter and just sort of fallen apart.
We just don't know.
I hope they're in somebody's collection and we can reassociate them later and they didn't just get destroyed.
Yeah, that'd be nice. So the fossils that were excavated in 1994 and 1995 by a team from the Sam Noble Museum in Oklahoma. And the type specimen is OMNH 66430. It's the left ilium of the smaller specimen, which is probably a juvenile. They also found parts of the shoulder, hip, ribs, and vertebrae.
So basically we just have the axial skeleton, the vertebrae and things in line with the vertebrae. We don't have any limb bones whatsoever or skull, or it looks like, depending on which vertebrae, much of the tail or the neck potentially.
We have enough to know that it had thunder thighs.
Just based on the hips.
So these Brontomirus fossils were housed, unidentified, at the Sam Noble, Oklahoma Museum of Natural History. In 1997, Jim Kirkland and others had considered these fossils to be, quote-unquote, comparable to Pleurocoelus, which at the time was the only known early Cretaceous sauropod from North America. Then Brontomirus was named in 2011 by Michael Taylor, Matthew Wadle, and Richard Cifelli. In 2012, Michael Demi did a cladistic analysis of titanosauriforms and found Brontomirus to be a nomum dubium because the holotype was too fragmentary and therefore not diagnostic, not distinct enough, which is why I say it might be this dubious dinosaur. But I just wanted to take a moment to talk a little bit about Michael Taylor, or Mike Taylor, who wrote this paper, because it's really interesting. He's a computer programmer, and he's got a PhD in paleontology, and he's named 3 dinosaurs, Xenoposeidon and Hastosaurus, in addition to Brontomirus, and he's published 18 papers, and he co-founded Sauropod Vertebra Picture of the Week.
Nice. Very much a sauropod guy, it sounds like.
Yeah. Apparently, he got into hunting for fossils about 20 years ago. When he was inspired, he was reading a paleontology paper on a long plane ride. Then he started reading through a bunch of books and journals. And because he's published so many papers, then he just started publishing papers, he got a formal PhD in 2009 from the University of Portsmouth. So Taylor became pen pals with Matthew Wadle, who also does Sauropod Vertebra Picture of the Week, and now he studies fossils in museum collections. So the discovery of Brontomirus helped show that there was more diversity in sauropods in the early Cretaceous. It was the 8th sauropod name from the early Cretaceous in North America. And other animals that lived around the same time and place as Brontomirus include theropods, ornithopods, crocodiliforms, and fish. And for today's fun fact, I took over this portion of the show.
Yeah.
There's this really cool tectonic time lapse of the last billion years on Earth, and you can watch it in 40 seconds.
I can't even imagine how much work went into that.
Oh, yeah.
Probably several lifetimes of work by various scientists.
Yeah, I guess in a way, because this latest paper that was able to put together this time lapse took a lot of previous papers information.
Yeah, you got to survey a lot of the Earth's crust to figure out when different parts formed and where they were in relation to other plates and all that.
Mm-hmm. And we'll share a link so you can watch the time lapse. So it was Andrew Meredith and a team from France, Canada, China, and Australia that published on the first continuous tectonic plate reconstruction of the last billion years on Earth. Because before, our models covered different time periods in different parts of the world, and these models were based on different assumptions and hypotheses. So the idea is to put it all together in one space. So again, you can see this animation in 40 seconds. It's really cool. You see the continents merging and breaking apart. And having this model means that scientists can look at the changes and look at Earth's systems and how they relate to evolution and then lay the groundwork for future studies.
Yeah, I think one obvious thing that they could add to it is sea level, because my very first question to Sabrina when you showed this to me was, does it include sea level? Because I'm always wondering about dinosaur migration, and you need sea level data in order to be able to see that. And this model doesn't have sea level data yet. It's pretty easy to spot because I immediately went to when the Western Interior Seaway covered North America, and it's shown as just regular old North America. So I guess you have to add geological height data to all of the continents too, because mountain ranges formed at different times. Then if you have sea level data, you could combine it and see sea levels change over that same billion-year period.
Yes, it's very much meant to be a starting point. And one of the things that they're saying is it was hard to reconstruct because the seafloor doesn't last long because it gets recycled into deep earth at subduction zones.
Mm-hmm.
So the team, they used geological data, they combined and modified existing models to make this coherent global model and then reconstruct Earth's tectonic pulse. And then they put that data into this software called G-plates. And then again, because the seafloor doesn't last long, there's no plates that are really older than 200 million years.
No sea plates.
Yeah. So they had to use a lot of indirect evidence to put it together. And they looked at plate boundaries and how they shifted over time. And they went beyond the continental drift theory, which is where continents moved over time relative to each other.
Yeah, when you go into the billion-year phase, you can't just take a snapshot and say, oh, it's moving 2 centimeters a year in this direction, because things were spinning different ways and moving in all sorts of different directions over a billion years.
Yeah, and around 720 million years ago, we had 2 massive ice ages where Earth was covered in glaciers, and this time is called Snowball Earth.
Mm-hmm.
And things like Snowball Earth are related to plate tectonics and the evolution of life. So, for example, according to Cosmos magazine, which published about this paper, they said, quote, large-scale weathering of mountain chains may have plunged us into an ice age. Global glaciers would have ground down mountains and sent a flood of nutrients out to sea, which may have caused bacteria to bloom and churn out oxygen, changing the composition of the atmosphere to the one we are familiar with today, the atmosphere that life as we know it evolved within, end quote. So basically, we have the ice ages, Earth is covered in snow, Snowball Earth, and then protozoa evolved. And then 625 million years ago, we have the first multicellular organisms. And then 500 million years ago, more life, which led to other animals like dinosaurs, and then eventually to where we are today. So again, this model, it's a first step. They say, yes, there's been a lot of guesswork. It will probably change in the future, but it's meant to be a good starting point.
Yeah, I really like that idea. I like having a universal sort of model like that because I know there are similar models that are used very often by scientists to look at things like how things were migrating, but to have it in one single animation where you can really see the detail of where the plates are is incredibly helpful, and it sticks in your mind a lot better when you can sort of see it all connected rather than trying to imagine gaps in between individual pictures, which might be better known at a specific point in time, but then you have this fuzzy picture in between.
Yep.
The coolest thing to me is how fast India moved when it smashed up into Asia and created the Himalayan mountains, and how fast Australia moved and how recent it was that it moved up from Antarctica much farther north and away from the poles and made it habitable, comfortable for people, really.
Which makes sense to me because a lot of times we talk about polar dinosaurs that are found in both Australia and Antarctica.
Yeah. Yeah, I knew it moved up there. I just didn't realize how recent it was. Same thing with India. Like, it's very recent that it smashed into Asia. Came all the way up from basically southern Africa. It's pretty crazy in the animation. It's like things are slowly moving, and then you see India just like cruise across the ocean, slam into Asia. It is a fun animation.
It is.
It's really helpful, too, if you pick different time periods where you're thinking about dinosaurs and you want to see how close different continents were and things like that. What was connected.
Yeah, so we had a lot of fun watching several times.
Yeah, I did a lot of pausing, too.
Yep. And that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe to us in your favorite podcast app so you don't miss out on any new episodes. And consider joining our community, patreon.com/IKnowDino. Thanks again, and until next time.